Hey, I'm Cromwell, and we're going to be looking at Meshroom today. Following the previous intro to photogrammetry, we will be taking a look at the software that we'll be using to create our 3D mesh. So, in order to get the software, we need to go and download it. So, you can see here that if you just do a quick search for it, you can find that the first hit on Google, at least, is Alice Vision's GitHub page. So, we'll just click on that. And it's a nicely designed website for Alice Vision, which is the company or group or framework that's responsible for the creation of Meshroom. You can see some of their software and libraries here. So you can download Meshroom directly from these links, or you can click on the actual page that's dedicated to Meshroom. And we can see that Meshroom is a free open source 3D reconstruction software based on the Alice Vision framework. And they've been so wonderful to provide that to us completely free of charge, which is great. So we'll hit the download link and it will bring us to their GitHub page in order to download the software. Now, a word of caution going forward is that unfortunately, at the time of this recording, we only have the Windows 64 architecture version of Meshroom and the Linux version. There is, as of now, no Mac version available. So for you Mac users, you're going to want to find an alternative. And the unfortunate thing about this, as I've found, is that Mac does not have a wealth of photogrammetry software available to it. In fact, all of the alternatives that I'll show you to Meshroom are all going to be either in Windows or Linux and not in Mac at all. So that's one kind of unfortunate thing. For those of you who are in my class in the lab, we have access to the other half of the room, which does have PCs that can run Meshroom. I've tried it myself and verified that it does indeed work. So for those of you who need to use that, it is available to you. So obviously we want to grab the one for our operating system. Now I've already downloaded this, so I'll show you what happens when we try to open it and how it works. The great thing about Meshroom is that it is a portable file, which means we don't have to run an installer, which means we don't need permissions in order to use it. We can simply open up the zip archive and drag it out onto our desktop or into our documents folder, wherever you're comfortable placing it. Now, before we do that, I want to make note of an additional requirement. So, unfortunately, this software is very specific and requires that we have some certain hardware. So, the requirement for Meshroom, it can be found down here. We need to have a CUDA enabled NVIDIA GPU. So, that's the graphics processing unit or the graphics card, if you're familiar with that. And it must be manufactured by NVIDIA and be CUDA enabled. So, it's a specific type of graphics card. Now, the fortunate thing about this is the majority of consumer grade graphics cards that you can buy from NVIDIA are CUDA enabled these days. If you're running with an old card from years ago, that might not be the case. So I would highly suggest you look into whatever sort of graphics card you have in your machine, and that can be done, with a Google search, depending on what sort of operating system you're working with and what sort of environment you're in. But essentially, we need to make sure that it has a compute capability of 2.0 or higher. And the way that we can do this is I have another page here. Simply search up NVIDIA CUDA compute capability. And the first link that comes up is CUDA GPUs. If we click that, it'll bring us to NVIDIA's developer site where we see a category of different types of graphics products that NVIDIA sells. The top three here are higher end, more professional grade workstation types of graphic cards. And then here we have the CUDA enabled GeForce products, which are more consumer grade. And these are going to be what you're going to see more often than not. So if I open this, the cards that I'm working with are the GTX 1080 Ti, which is right here, and the GeForce GTX 1080, which is also right here. Both of these score a compute capability of 6.1, which is more than enough. For those of you who are using notebooks or laptops that are Windows and are running with an NVIDIA GPU, you can find that in this column here. And you'll see that the lowest scoring card here is the 480M, and it scores a 2.0, which still meets our requirements. I have not tried this kind of card, so again, approach at your own caution. This will probably take some time for processing. However, if your card is on this list, then it would most likely work with Meshroom. So just keep that in mind. I know it's kind of annoying. It is kind of early on to be seeing free and open source software for photogrammetry, which is kind of amazing that we have Meshroom available to us. Um, I don't know if they're watching, but a big thanks to Alice Vision for making that available to us. A lot of other 3D photogrammetry software is pretty intensive and it's very technical. Meshroom is very well optimized for new users, as we'll see when we break into the software itself. But other softwares are very expensive, they're very technical, there's a lot of setup for some of them, and it can get difficult to really break into understanding how to use that software. So good on Alice Vision for making that available to us. Again, thanks so much. Um, an alternative to Meshroom, if you want, is 3DF or the 3DF Zephyr or 3D Flow Zephyr. They provide a free version of the software, which we'll see here. They do have a paid version, which you have to buy, and the free version does have some limitations. So this is free for personal use only, not to be used for commercial uses. Um, you can use up to 50 images per project, so there's a bit of a limitation on that, but they say it's great for learning photogrammetry. And one of the limitations that come with it is it does come as an installer, which means you will need permissions on the machine that you're using in order to install the software. At least that was my experience in the past. So that's a big difference between Meshroom and 3D Zephyr, and the reason why I chose Meshroom over 3D Zephyr. That being also that Meshroom I think is a little bit easier to use out of the box, and so that's why we opted not to go with Zephyr. Although it is an alternative in case you're curious. Another alternative is Autodesk Recap, previously known as Autodesk Remake. So if we go to their page, Autodesk is kind enough to offer an educational license for students with a university email. I believe it's a 3-year educational license that you can use in order to get this piece of software along with other really well known Autodesk software such as Maya or 3D Studio Max. And you can use it for free under an educational license for 3 years, I believe. Just note that the educational license has some limitations. You can't use the software commercially, and I believe technically under the license. Now, don't quote me on this. I'm not a lawyer, but I believe that under the educational license, that Autodesk technically owns whatever you create with their software. So be aware of that. I've never actually heard of them making a claim of that or going and taking anybody's assets or anything like that. But I have heard rumors that that's the case and how the license work. Again, I'm not a lawyer. Don't quote me on that. But if you would like to try out some kind of professional grade photogrammetry software, Recap is a good option for students who have a university email. One of the limitations, again, however, it is only Windows software, although I do believe you can use it with an iPad. So do with that what you will. All right. But for our case, I'm just going to close these. We're going to be sticking with Meshroom. So I'm going to leave that there. I'm going to open up a viewer, just bring it off to the side. Now, I downloaded Meshroom already, so it's already on this machine. And I'm going to find it here. So once you have it downloaded into your downloads folder or wherever you keep things, if you double click on the zip file here, it'll actually bring you into this folder here. And you can just take that folder and dump it out onto your desktop. Now, like I said, I've already done that, but essentially you'll have all of these files inside of a Meshroom 2018.1.0 folder, and that's what we're going to be looking at using. So let me just get to that real quick. All right. So now that I have this open, I want to show you. If I double click that and open Meshroom, you'll see we'll get a command prompt, and we want to leave this open. Don't close that. That'll be useful in case we need to debug Meshroom, which we really shouldn't have to. Like I said, most of this just works right out of the box. There is one error that I personally ran into, and it was an error that was very specific to my own situation. And so I will go over that very slowly because it is a bit technical. But in case anybody else runs into something like this in class or on their own, I want to make sure that I document it well so that people can follow along and solve it for themselves. So as we go through this process, I will make a note of that. But other than that, basically, this is plug and play. So once you have the images that you want to turn into your 3D object, we have this little panel here where we can drag those images in or the entire folder in, and we'll see little thumbnails of those images. And Meshroom will begin to kind of process them and see if there are some images that are unacceptable and other images that are fine. And then we can view those images here in the center. And then here on the right side in the 3D viewer is where we will view the object that Meshroom will spit out for us once it's done processing all of our photos. Now at the bottom, you'll notice this big intimidating chain of nodes. And basically, this is the process that Meshroom is going to go through in order to generate your 3D mesh. Now, you can move these nodes around, and each of them have separate settings, which we can see here in our attribute panel. I would highly recommend, if you're a beginner, do not mess with these settings. If you screw up these settings, simply close down Meshroom and open up a new instance, or you can say File, New. It's totally up to you. But don't mess with these settings if you're brand new. One of the things that we're still waiting on from Alice Vision is a set of clear documentation. As of the time of this recording, there is no official documentation for Meshroom. So, although I understand certain things inside of each of these categories and kind of what they do, we don't have a set of clear documentation or a manual to go along with this software that can really point out to us exactly what each setting does. So, I would, again, recommend that nobody mess around with these settings unless you're familiar. You can go around and browse their GitHub page. There have been people who have left comments. There are plenty of videos online of people using the software, and some that even go as far as playing with a couple of settings here and there. But for our purposes, we are simply going to leave everything as is right out of the box just to keep things as simple as possible. So what I'm going to do is I'm going to quickly set up my project files. I'm going to pause the video and do that really quickly, and I'll see you in 2 seconds. All right, so I've taken the time to set up a folder for my project, and I'll show that to you here. So here I have this soldier folder, which I have placed another folder in with all of my photos, which are for some reason not showing up. Let me try to paste that. Maybe, yep, there they are. So let's just change our view really quickly. Extra large icon. So there we go. We have all of our photos of my little soldier statuette that I have here in my home, and I've taken photos of it. They're not the best photos. I didn't have a tripod at the time, and so some of the settings with lights and stuff like that were kind of finicky. However, I do know that this actually does work, and I have an example of it that I'll show you in just a moment. All right, so here's a quick example of the result that we can expect out of this process. I have the actual 3D model of that statuette that I took photos of, and we can also take a look at the wireframe. You can see that it's quite a dense model. There's a lot of information there. And I'm using currently a free version of Sketchfab, which means the site has limitations for how large the file can be that you upload. I believe it's a 60 megabyte limitation. I could be wrong on that. But I do believe, I definitely know that there is a limitation on the free account. And I think there's even a limitation on the paid account as well, just to keep their bandwidth within reason. But you can see here that the statuette was actually recreated pretty faithfully. It looks pretty believable, and there's quite a bit of detail captured on that, even though I didn't have the best lighting settings. Now, of course, with your projects, I would highly recommend use the best lighting settings you can get, use a tripod, and make sure you set up everything properly. Set that up ahead of time. Unfortunately, I was a little strained on time when I did this, but you can see here that it came out relatively well. It captured some of this even kind of dainty detail at the top here with some of these feather looking things that are rather thin. It captured them pretty well, and it turned out quite all right. So that's an example of what we can kind of expect here. So here, let's open up Meshroom, and I'm going to grab those photos from the folder that I set up, and I'm just going to drag them over here into this image setting here, this image box, and there we go. We have all of our images inside of Meshroom. So if everything goes according to plan, which for I would say like 99% of all people who shoot with a camera phone or a common phone or a common camera, this will go without a hitch. You simply drag your images in here and then you just press start. However, before we press start, we should probably save it first. So let's go File, Save As, and I'm going to find that folder. So I'm going to go to my Photogrammetry folder here, find my soldier, and just name this soldier, and it will save it as a Meshroom graph file, so a .mg file. And the reason we want to save that is so that when we start this, Meshroom is going to create a cache file. And that's going to store all of your images. It's going to store all of the object files that Meshroom ends up creating where you saved it. If you don't do that, however, Meshroom will ask you to use a temporary file location, and that will place it somewhere on your hard drive, and you may have to fish for it. And so to kind of avoid that, we're simply just going to save the file ahead of time so we know where it is. So if you're ready and you're happy with all your images, if there are any images that you don't like, say, for example, this one's a little too dark in the front, you can right click and say remove, or you can also find where that image is by say show containing folder. However, I'm going to leave all these images here. And then once you're happy with it, just simply press start at the top. And you'll notice we get this little moving bar that kind of shows the progress. So the green is what's been completed, and the yellow is what's being worked on. And this kind of teal turquoise color is what is remaining. And you can also see that represented down here in the nodes. We'll see that the camera in it was successfully completed, that we're working on feature extraction, and the next process that we'll be worrying about is image matching. And basically, this will take some time. Generally speaking, it goes relatively quickly, and then we're going to get a bit of chug here at depth map. This can sometimes take upwards of 15 minutes all the way to an hour and a half to 2 hours, depending on the kind of hardware you have in your machine. So expect to spend some time in this. You can leave this in a background task, for example, go do something else, work on something else if you want. Preferably something that's not super graphics card intensive if you can avoid that, so that this has as much resource allocated to it as possible. But essentially, you can leave this running and do something else while you're waiting for it. Um, if you're in the lab, I would say don't leave your computer unattended. Stay there, maybe work on something written or read something if possible. You can type up Word documents in the background, stuff like that. It's not a problem. You can definitely do that. So we're basically going to wait for this to finish processing, and then we'll see the end result later on. So I'm going to cut the video short here and show you what it looks like when we get to the end there. All right, so I've gone ahead and cheated a little bit and loaded the old version of this file that I had just to avoid having to wait long amounts of time. And you can see here that everything went off without a hitch. We got all the way through this with an entire green bar, and we can see that at the top. A thing to note that I've had in the past, and it hasn't happened to me recently, but in the past, I've had issues with the depth map. Maybe it was my graphics driver or something that wasn't completely up to date, but what would happen is I would get a part way through the depth map and it would hit an error and then it would stop processing and throw an error. And as far as I know for that, I think it was a graphics driver issue. I wasn't too certain about it, but essentially what would happen is it would build a percentage of the green bar and then it would throw a red section, and essentially all I had to do was hit start again. And the great thing about this is the cache will actually save all of that green progress. And then when you hit the bar again, if it crashes, it will continue to build that progress and you won't have to worry about it. As long as you can get through the depth map, as long as it keeps progressing. If you have an issue where it won't progress, then, leave a comment or try to reach out to somebody, maybe search it online or talk to me in class, of course. I'm there to help you. I've never run into that as an issue. However, if that is the case, definitely reach out. Otherwise, just continue to be patient with it. Hit the start button again, let it build up that progress until it gets through the whole process here, and then we get to the texturing stage. And what you'll have is if we zoom in here, just with the middle mouse button, you can move the scene around by clicking and dragging your middle mouse button. And because you're on a PC, you probably have a 3-button mouse, but if you don't, it might be a little bit hard to navigate this. But you'll see that we have what's called point cloud or dense cloud. There's many different names for this. If I click with the left mouse button, I can kind of drag around this. It's kind of off orientation, so I'll try to rotate it a little bit with some of these settings up here and maybe get it into place. Let's see. Oops, that's not the setting I want. Zoom out. So it's a little off orientation. We can kind of rotate it around in 3D space here and try to get it kind of on the grid somehow. That's probably as close as it's getting. Now, we don't need to exactly perfect this. This is just for the sake of being able to visualize it in the viewer, because we are going to take the mesh that's generated from here and bring it into Blender. You can also do so in whatever other 3D program that you choose to work with. But essentially, we get this point cloud data that's representative of the model. And all that's left to do is hit load model. So I'm going to do that. It'll take a second to load through that. So just bear with it. And then there it will generate the mesh. And if we hit this little check mark here next to SFM, which I believe means structure from motion, which we talked about a little bit in the intro to photogrammetry video. Now we can turn that off and you can see, wow, it's created the object and it's done so with pretty good accuracy. It looks pretty good. I'm pretty satisfied with that. And so now what we're going to do is it's already saved all of these files into your folder, and all you have to do is go into that folder and bring those files into Blender. So I'll show you how to do that um, right now. So once you're happy with this, you can either go through it and save it again if you need to, or simply close it. I'm just going to come over here and bring you into the folder here. So I already have a Blender file set up with this. So I'm just going to open that really quickly. All right. So we've loaded in and you can see that I've gotten the file in here into Blender and I cleaned it up a little bit just to make sure that everything was working well. All right. So let's imagine that this is not what you get in your scene and it's not going to be this way. My Blender is all customized and everything. So I'm just going to quickly revert this to the factory settings and it's going to be very different. So this is what your Blender is going to look like when you open it up for the first time. And I'm going to give you a quick introduction to the UI as well as how to navigate very quickly for those of you who don't. If you are familiar with Blender, feel free to skip ahead in the video. This is for my class students that have never used Blender before, and it can be quite intimidating. But it's not that bad, I promise. I I like using Blender, and a lot when I tell people that who've worked in the 3D industry, they look at me like I have 2 heads. It's perfectly normal. Okay, so the first thing that we have is we have a bunch of objects in our scene. So this is like the default scene setting that we have for Blender, and this is the 3D view in the center. On the left, we have a panel that's collapsible. You can close that with the T key, so we'll close that. And then over here we have our outliner, I believe is what it's called. Yep. And that's where all the objects in our scene reside. So you can see we have 3 objects here. We have a lamp, we have a camera and a cube, and then here we have our lamp. Oops. Our lamp, our camera, and our cube. Now, I don't like to have these things here. I like to just delete them when I open up the scene. So what I'm going to do is make sure my mouse is hovering inside of the 3D view. I'm going to tap the A key so that nothing is selected. If you had anything selected, that's how you deselect everything, and then you can tap it again to make sure that everything's selected, and you can tell that you've done this successfully because things will be highlighted in orange. And then what we can do is we can hit X, and unfortunately, I have some add-ons that I forgot to turn off, so let me go sort that really quickly. I apologize for that in advance. For some reason, let's just X out of this. So I'm probably going to create problems for myself later on. Yeah, so we'll just search it. So the space bar for me and then hit delete and then just object delete. Hit OK. Now for you, you can simply press the X key and it'll ask you if it's okay to delete those objects. Unfortunately, some of my key bindings were a little out of whack because I have Mesh Machine installed on my iteration of Blender. That shouldn't be a problem for you. Okay. So now that we have an empty scene, you should know that selecting objects inside of Blender by default is a little odd. So in case you were wondering how that was done, it's done with a right click. Where every other piece of software uses a left click, Blender uses a right click. And you might be thinking to yourself, well, why in the world does it do that? Well, if we go to the File menu and go to User Preferences, we can go to Input and we can see all of the different settings that we have for Blender. So for example, if you're familiar with 3D Studio Max or Maya, you can actually emulate the way that those applications work inside of Blender. However, we're just going to stick with Blender. The reason why we get a select with right is because if we need to emulate a 3-button mouse, if I click left here, you see that option goes away. And for those of you who are working on the Macs in my class, you're going to need this option because the Mac mouse does not have a functional middle mouse button, or at least some of them don't because they break and that little ball in the middle of the mouse doesn't work. So keep this option to select right, and you can click emulate 3-button mouse, and that allows us to hold the Alt key in order to move around the scene. So that's holding down the Alt key and left clicking on the mouse allows us to orbit around the scene. Holding down Alt and Shift and the left button on the mouse will allow us to pan around the scene. And then if we hold down Alt, hold down Shift, and hold down Control, I know it's a lot, click and hold the left mouse button and you can zoom in and out of your scene. Now, if you have a 3-button mouse, it's a lot easier. All you have to do is hold down the middle mouse button to orbit, hold down middle mouse button and Shift in order to pan, and then you can zoom by scrolling in your middle mouse button or scrolling in your middle mouse scroll wheel in order to zoom in and out. But for those of you that don't have a 3-button mouse, you're going to want to use those settings that I just described. Feel free to rewind the video and review that as many times as possible. Now, I like to leave this off and use left click for my setup. Again, use whatever you need to use. You can also emulate a number pad in case you don't have one of those, which will basically assign the functions of the number pad to the numbers at the top of your keyboard. And essentially, what that does is it allows you to switch the views. So, for example, 1 is going to give you a front view, 3 is going to give you a side view, 5 is going to switch between perspective and orthographic, as you can see here. And we have a whole bunch of other views. So, for example, 7 is the top, 8 and 6 will give you nudging views, where you can kind of nudge the camera. The same with 2 and 4 will do the same thing, but in opposite. So there's many different ways that you can make stuff happen inside of Blender. I have a whole series on this. If you're curious about that, feel free to go and watch that. Um, and then carrying on, we have a couple of other sections. There are 2 more panels that I would like to go over. So here we have all of our object properties for things in our scene. So for example, this is our render properties, and then we have some render layers and some other tabs here that we're really not going to get into. And then at the bottom, we have a timeline for animation. We don't need that at all. In fact, a lot of my tutorials begin with this entirely collapsed because I don't like using it. And then there are 2 other panels that can be opened, the N and the T panels. I like to leave them closed. Um, if you want to reconfigure the interface of Blender, you can click and drag the in between some of these divisions. It is a little weird to get used to this at first. So for example, collapsing a panel, you'll see that there are score marks in the lower left and the upper right side of each of these panels. There's even some at the top here. This is your default file menu. And you can control Z and undo stuff and control shift Z and redo stuff inside of Blender. That's all standard. But essentially what we're going to do is we want to find this score mark here and click and drag down. Do not click and drag up at all. Otherwise you're going to create, you're either going to collapse it up here or you're going to create a new menu. So we want to close this down. If you click and drag up, it'll create another menu, and you can do this a bunch of times. And I know a lot of people get confused creating like 1,000 of these. So just be careful about that. Click and drag down. You'll see this little arrow appear, and then just do that as many times as you need to collapse. So we can keep our workspace as clean as possible. Here I'm going to switch this over to cycles just to make sure that I'm using the correct render engine. Again, this is not something that you need to be completely engaged with. This gets a little bit deeper than we're going to go. And again, if you're really curious, watch those videos that I put up. And there's also a plethora of other educational material on this. So now that I've spent a significant amount of time going over the Blender interface, let's import our object. So I'm going to go File, Import, Wavefront OBJ. I'm sorry about that. Wavefront OBJ. This time it's in precompiled. For you, it's probably going to be Inside Soldier, Meshroom Cache, and Texturing. But for me, I'm using my precompiled one. So precompile, Soldier, Meshroom Cache, Texturing, and you'll find this big, long name folder here. And inside of that, you will find a .mtl and a .obj file. This is the file we're going to load into Blender. So just click on that and hit Import OBJ and just wait. It's going to take a little bit of time. It shouldn't take too long, but it will take a little bit of time. So bear with it. I'm going to cut the video short, and I'll see you in a second. All right, so it looks like our object came into Blender without any problems, and this is what it looks like. So again, zoom in with your middle mouse button. Hold down Shift and middle mouse button in order to kind of move over to this. Again, if you're using the right mouse button select scheme and you don't have a 3-button mouse, use the Alt key, Alt Shift, and Alt Shift Control in order to get your zooming and your panning and your orbiting. And essentially, I want to make sure that I can see the object and we can see that it's kind of off center here. So we're going to look at solving that. So let's select it by clicking on it. And you can see that it'll change from a dark orange highlight to a bright orange highlight. And now we're going to learn about moving our object in 3D space. Again, this is mainly geared towards the newer students that have never used Blender before. So you'll see here that the object appeared here, but we have this handle here. And this just means that the origin for our object, which is a point of reference for our object, is appearing at the center of the world, and it has a control around it. So this is the transform widget or transform gizmo. There's a billion different names for this thing, but it's basically the handle that you'll use in order to move this thing around. So you can see here that we've got three arrows. We got a blue one, a red one, and a green one. And these represent the three axes about which you can transform your object. The blue one is the Z axis. Sometimes the blue and the green ones will be switched around in different 3D applications. In Blender, it's the Z axis for up and down, the Y axis for this direction, and the X axis for this direction. So here we can move it in this axis, in this axis, and in this axis. I'm just going to hit Control Z to undo that. And now what I want to do is I want to move this guy to the center of the world, and you can see we have the intersection of the X and Y axes. And I kind of want him existing there. I kind of want to put his feet there. So I'm basically just going to try to align the collision of these two axes on his feet. All right. So now what we can do is there are a bunch of other options down here. If we hover over this, we can see transformation manipulators. We can also see a rotation manipulator as well as a scaling manipulator. I don't know why I said um, transform there. So this is translating, which is moving, rotating, which is self-explanatory, and scaling, which deals with size. Be careful not to scale it in one direction necessarily. We can leave the scale as it is. That's going to be fine. The only time we have to concern ourselves with scale is when we go to 3D print this. And for those of you who are doing that in the lab, I would suggest consulting with the fine folks at Retner in order to have them help you make sure that you get the proper scale out of it. I can show you how to set up scaling inside of Blender if that's something you're interested in, but I'll save that for specific cases and not spend too much time talking about it here. All right, so now that we have this at the center, we're going to hit the T key and open up our transform menu. And we're going to change set um, origin to geometry. And what that does is it puts this little dot here in the center of our geometry. Now, you'll see this little floating thing here, and you might wonder to yourself what that is and why it moves around when you left click. For me, it's a right click, but for you, it's probably a left click. And essentially, what this is the 3D cursor. You can actually reset that by hitting Shift C on the keyboard, and you'll see it'll reset to the world origin, which is again the collision of those two axes that we see here, the X and Y axes. And essentially, what this does is when we create objects, it will allow those objects to be spawned into the world from wherever this point is. So if I move it here and I try to create something, it'll create that object there. Now, of course, I don't want everything to be relative to over there. I want it in the center. So again, I'm going to hit Shift C and return that to the center of the world. Now, the reason why I wanted to do that is because I want the origin for this object to be down here, not right here. And so I'm going to go back to my set origin and I'm going to say origin to 3D cursor. You could also use this really long and convoluted shortcut key here. That's actually the way I prefer to do it just because I've memorized it. But you can also use this panel here. Just press that and you'll see that the orange origin for our object has jumped down here where we wanted it to be. So now what that allows us to do is if we come down here and activate our rotation handle, we can actually rotate our object about his feet so that we can get him in line with the grid. So remember how I mentioned that you can activate the um, number pad keys on your keyboard in order to emulate them if you don't have them? Well, if you do have the number pad keys or if you've emulated them, what we want to do is go into a side view so we can more accurately line this up with the grid. So I'm going to press the 3 key to get into a side view, and it's going to flip my camera because I didn't realize it, but my entire object's upside down, and I'm going to press the 5 key. And what that's going to do is it's going to flatten out my view from a perspective view into an orthographic view. And so now what I can do is I can rotate this character. Whoops, let's right click to cancel that. So if you create any transformations that you don't intend to keep, like I'm doing here, I clicked and it's moving this object around, what you can do is you can right click and cancel that rotation or that translation or that scale and just bring it back to where it was before. Now, one of the problems that I'm running into right now is because I'm in an orthographic view, I can't actually see the handle for rotation. The only handle that I can see is actually the rotation around the y axis, which is being lit up right now. And I don't really want to, well, I can use that to get the statuette upright, which is useful, but then I can't actually rotate around any other axis except for maybe Z. I can do that. but I need the x-axis in order to kind of fix the direction in which he's facing, because you can see this is still skewed in this direction. So one way we can do this is we can use the shortcut key R in order to create a rotation. Now, because we're in our orthographic view, the only rotation that's being affected right now is the axis that we're directly facing, which is the x-axis. So if I use my middle mouse button, or for those of you who are emulating Alt and left mouse button, you can actually tumble out of that, and now you can see that there's the x-axis. It's finally appeared to us, and we can see that handle there and control it in this way. Now, the problem that this is going to raise is that if your camera view is not directly snapped onto the side like this, so say we're kind of out of there, if we hit the R key, it's going to rotate based on our camera view. So I would suggest using this option here just by clicking and dragging that. Or you can use the shortcut key R and then press Z in order to, or sorry, not Z, X, to constrain the rotation to that axis. And you can see that that red X axis is actually lit up now that we're constraining our rotation to only that axis. And that works with any of the other two axes as well. So R and Z, which is the mistake I made earlier, you can see that now the Z axis has shown up, and that's what we're rotating around. And R, Y is now allowing us to rotate around the Y axis. So that's a very good way to get control of our object. So now that it's in place, I want to rotate it in the Z just a little more. Go to the front and make sure. Yeah, that looks okay. I'll hit the 5 key to go back into perspective and the T key to close it. And now you can see that our statuette is in place. I can reactivate the movement controls and just kind of move this up a little bit. And there we go. I'm pretty happy with that. So one interesting thing that we should make note of is we want to apply the transformations that we just created for it. If I open up the end menu, you can see here we have transformation data that we've created. And if I were to zero all these out, this object would go back to the original position that it was at. I don't want to do that, of course, but we want to apply these so that they are zeroed out. In the case that we need to do something to the mesh later on, we can get a lot of distortion if we don't zero all that data out. So the way that we do that is making sure that the mesh is selected again with that orange halo around it. We can hit Control A and we can apply our location. And you'll notice that all of this is now 0. We can do it again and say rotation and scale. And then all of a sudden our rotation data is 0 and our scale is all set to 1. We didn't actually change the scale at all, so that should have already been 1. But I like to apply that. And then if you want to do it separately, they do have separate options there as well. So let's hit N to close that up. And there we go. We have our object. If we switch our viewport shading, so that's down here, by default it's set to solid. We can also check the wireframe, which is going to show us all of the messy topology that we have. And topology is basically the surface quality of our object. And then if I go to material, you can actually see the material on this character or this object. Pretty cool. So I want to do a little bit of cleanup on this. So again, I'm going to go into the side view and hit 5. So that's 3 and then 5. And now what I'm going to do is I'm going to switch from object mode into edit mode. And this is going to take a second because there are a lot of points. If we actually look up here, we have 758,000 vertices, which are all of these little points that make up this entire model. So that's a lot. And what I'm going to do is deselect everything by hitting A. And then I'm going to hit Z, which is the equivalent of coming down here and choosing wireframe. And then what I'm going to do is I'm going to go select, and then I need to find my border select, which is the B key. And I'm just going to click and drag up to here, being careful not to select the floor in its entirety. And you'll see we've selected all of these points underneath it. And I'm just going to hit X and say vertices. Now, fortunately, our menu has been corrected because we are in edit mode, not object mode. So keep in mind that based on the mode you're in, you're going to get different options. So be very careful and very attentive to what mode that you're in. So right now we're in edit mode. So I'm going to hit X and I'm going to delete these vertices. And it'll take a second again because it's a really dense mesh. And there we go. We've cleaned up that bottom portion. I'm going to hit the 1 key now, and that's going to switch us to the front view. And what I want to do is, again, I can go select border select, or I can hit the B key, and you'll see I'll get this little crosshair. I'm just going to select this area, and I'm going to do the same to the other side. somewhere around here probably would be fine. And I'm going to hit X, and I'm going to delete these vertices, and just give it a second. All right, there it is. And now I'm going to hit the 7 key, and that's going to give me a top view. Now, this is going to be a little bit tricky because there are so many vertices that it's hard to see the contour of our soldier. So we need to be somewhat conservative with how far we're willing to go in to select. Otherwise, we could end up selecting our soldier and deleting parts of him. So I'm going to hit B again, and I'm going to select right up to about here, I think should be okay. And then I'm going to pan my camera, and I'm going to do the same on the front half, maybe around. Let's try here. Let's get a little bit bold. Try there. And to check this, you can hit the 1 key and see if you've selected your soldier at all, or you can tumble out of the view and hit the 5 key. And it looks like we have preserved our soldier, so we don't have to worry about deleting any part of him. And then we'll hit the X key and delete those vertices as well. Now you can see that my viewport is starting to chug. A little bit of that has to do with the fact that I'm using screen recording software. And of course, it's just an insane amount of vertices. We still have almost 560,000 vertices here. So it's a lot of data for Blender to handle. So I'm going to hit Tab, which is the same thing as moving back into object mode. You can toggle between the two by hitting Tab. And then I'm going to switch back into our material mode right here. And now you can see that things are a little bit faster, a little bit easier to manage. And there we go. We've kind of cleaned up the ground underneath our guy here. And so it's a little bit easier to deal with. Now, another way that we can clean this up and kind of reduce the poly count. So when I say poly count, I'm referring to these numbers up here. We have vertices, which are the points, edges, which are not accounted for in this menu right here, which are the lines that connect the points, and then the faces, which are the connection of the points to form the surface. So if I can show you this, I can zoom in. Let's go into our solid mode here. And if I zoom in far enough, you can see that each of those points make up these triangles that form these little faces or form these surfaces. And yeah, that's what is referenced when we say faces. So we've got 1,000,000 plus faces here, which is a lot. And then the tries are, so faces and tries can be the same thing, but are not always the same thing. The difference between that I can demonstrate really quickly. If we take a plane, I can actually show you. We have the vertices, which are in the corner of each of these, and then the edges, which are 2 vertices, and then the whole face here is all 4 of these vertices connected. Now, the difference between faces and tries is that we can actually connect this in the center, and now we have 2 triangles. So here we see that we have 2 faces, which are 2 triangles. However, if we get rid of the center here, whoops, let's undo that. Undo it to before I created that, we have 1 face that is 2 triangles. So that's essentially what those counts are referencing. All faces are broken down into triangles once they're rendered by a render engine. I know that might not mean much to you, but that's essentially what that's relating to. So now what I'll do is I'll just delete this because we don't need it. If it'll let me. Yes, okay, there we go. And so now we have our object. If you wanted to 3D print this, we would have to go through a little bit of legwork to get the bottom of it closed. And I'll show you how to do that really quickly. So we'll go into our material view for now. I'm eventually going to make it out of material view, actually. I'm going to hit tab to go into edit mode from object mode. And I'm going to hit Z to go into wireframe. And again, this is really, really difficult to navigate simply because of the fact that it's so dense. So I'm going to go and hit 3 and hit the 5 key so that I'm in orthographic. I'm going to zoom out. I'm going to hit the B key, and then I'm going to select all of my soldier all the way down to his feet, but I'm not going to select the ground. So that we have all the soldier selected, and then I'm going to hit select inverse. And again, this might be different depending on your subject material. And now that I have the bottom selected, I can hit X and say delete those vertices. And it's going to take a second because, again, it's a lot of data. And now I can kind of tumble out here. We can hit the Z key in order to get back into our solid mode. I'm going to keep zooming in here. And I'm going to hit the 5 key so that we get into our perspective. Now, there's a little trick that we have to do in order to close off the bottom here. Now, one thing we could do is we could add a cube or a cylinder and we could just kind of attach those two objects to each other, so the soldier to that cube or cylinder, and I can show you how to do that. However, I just want to close this. So what I'm going to do is I'm going to change from our vertex mode, which is what we're in right now. We've been in that the whole time, and I'm going to switch to edge mode. So there are three selection modes. We have vertex, edge, and face. And what I'm going to do is I'm going to select edge mode. I'm going to hold down the Alt key, and I'm going to select an edge on the very bottom of the soldier, and I'm going to do that twice. So the first time you can see it selected a small area. The second time I clicked on that same edge, it selected the whole thing. And I'm just going to hit the F key. And what that's going to do is it's going to join all of those edges with one face on the bottom of the soldier, and I'm just going to drag this down a little bit using the X handle, or I'm sorry, the Z handle. I keep confusing those two for some reason. So the Z handle is the blue one. I'm just going to drag it down, and you see that it's stretched a little bit. And now I'm going to hit SZ0. So that's in order. I'm going to hit S, then Z, then 0. And what that does is it flattens out the bottom of our soldier, and now you can see it's closed, which means we can 3D print it. So as long as there are no problems with our mesh, as long as it's watertight, and what I mean by that is if you were to go inside like this and you were to fill it with water, it wouldn't leak at all. As long as it's watertight, you should be able to 3D print it, although there are some considerations with, for example, these little earring looking things here. Those might need supports underneath it. You may want to reorient him so he's laying down, for example. So if we rotated him like this, that might be a little bit better for 3D printing. Again, if you're one of my students who are thinking about 3D printing, consult with the fine folks inside of Retner and make sure that you get their blessing and their help in order to make sure that this goes off without a hitch. So really quickly, I'm going to change my origin to his feet. So I'm going to hit Tab into edit mode. With this bottom face selected, I'm going to hit Shift S, and that's going to snap to our selected surface. So I'm going to say cursor to selected, and you'll see the 3D cursor jumps up there. I'll hit Tab to go back out into object mode, and again, you can do that down here. And I'm going to use that wild shortcut, Control Shift Alt C, and say origin to 3D cursor. Again, if that's too much, simply use the set origin here and say origin to 3D cursor, and that's the T menu. Just hit T, and now that origin is set there, and I can move this back down. And I can actually turn on snapping, which is over here, snap transform, and I can also turn on absolute grid alignment, and I can move this so that it's snapped directly to the grid, and he's standing directly on top of the grid. And then again, Control A, we're going to apply our location, our rotation, and our scale. And there we go. We have our guy positioned directly on top of the grid. If I go back into our material mode, we can see it's looking pretty good. You'll see that there's a bit of a weird texture thing going on the bottom. The reason why this is happening is because we created that face, and so Blender doesn't really know what part of the texture or the image that is being projected onto this should be mapped to the bottom. Now, fortunately for us, we're not really going to see this if we 3D print it, or if we upload it online, you might see it. A good way to hide that is hitting Shift C to reset our 3D cursor. We can add in a box and we can scale it. So that's SZ to scale it in the Z direction, and we can move it down. Hit S to scale it some more. I'm going to turn off my snapping and move this down here. So you can hide it this way if you really want to. You can also create a cylinder or any number of other things to put underneath it. And there we go. We don't have to worry about seeing that underneath. If you wanted to correct that, I could teach you how to do that. If you're one of my students in class, or if you're really curious, leave a comment down below and ask me about it, and I could show that off. However, I don't want to waste too much time on that. It gets a little more technical, talking about UV maps and texture projection and all sorts of fun stuff like that. Now you might be wondering, where is this texture coming from? And I can actually show that to you if we open up our Meshroom file that we saved before inside of the cache. So we'll open that up, go to texturing, which is, if you remember, that's where our files are stored. That's where our files are stored. I get so tongue twisted sometimes. All right, and then we'll open this up. You'll see that we have an MTL, an OBJ, and there's also a texture image in here, which was created in Meshroom, which is where we're getting this texture from. I'll just collapse that. And if I open that up, you can see here is all the texture for that soldier, and it's broken up and laid out in a very incomprehensible way. But the cool thing about this is with this MTL file, when we import it into Blender, it's actually able to read it in a way that makes sense to us visually. So it's an interesting way of how Meshroom compiles textures that can be projected onto a mesh and read in a way that is sensical to us. But if we were to try to understand the layout of it or anything like that, it just seems like a big mess. And there are ways to correct this and go about it that are well beyond the scope of this course, but I figured I would mention it in case anyone was curious. All right. So once we're happy with this, we can of course go File and Save As and save this as a blend file, and we can upload it online. We can also export it. So File, Export, and we can export it as an OBJ file, which we can then hand off to a 3D printer if they accept OBJs. We can also use an STL, which is a very common 3D printing file extension. And then we also have an FBX and Collada. Those are other kind of familiar extensions there. 3ds is another really common one. Um, but for 3D printing, you're more than likely going to go with an STL. Again, ask your printer what they accept and what they are expecting from you, and that's one way to do it. Now, before I draw this to a close, I'm going to get rid of this squished cube down here, and I'm going to talk about optimizing this mesh a little bit because, as you can imagine, 439,000 vertices and 877,000 faces is a bit of data still. It's still quite a bit. And as I mentioned previously, uploading this to Sketchfab, there is, I believe, a 60 megabyte upload limit on a free account, and even the pro accounts that you have to pay for still have some sort of limitation in order to keep their bandwidth within a reasonable quota. So, in order to optimize this a little bit to get our file size down a little bit smaller, there are some things that we can do. So once we have the mesh selected, we have to find this tab over here with the wrench and we can add some modifiers. So the number one modifier that will make photogrammetry a little less dense and a little more manageable is the decimate modifier. So if we hit add modifier and find decimate and add that, you can see that we get this decimate modifier that uses a ratio to reduce the number of vertices and thus edges, tries, and faces in order to keep it a little bit lower, but it will do its best to preserve the outside surface of the model so that way we don't have to worry about it collapsing or having problems. Now, there are limitations to this, and we're going to see this really quickly. So, change the ratio from 1 to say 0.5 and hit enter, and you'll notice that it will kind of lag for a second, and that's again because it's trying to process through all nearly 500,000 of these vertices. And so give it a second, we'll get our little ring of death of waiting, and there we go. It's finally finished, and you can see now we have 219,000 instead of the 400,000 that we were previously at. And it looks relatively the same. So you can really push this ratio. You can go as low as 0.01. However, the lower you go, the more it's going to decimate and it can run into additional problems. And we might see that when this updates. So now that it's updated, you can see that if I zoom in here, some of the texture is starting to become a little bit muddy. You can see that there are these weird little fractures that are occurring. And this is because Blender is reducing the number of polygons, but it's trying to preserve the surface quality. And it's not really understanding how that texture needs to be mapped across all of this at this point. So, like I said, there are some limitations to this. Now we're down at about 4,000 vertices, which is quite optimized. If I hit the Z key, you can see that it's a lot less dense. We can actually start to see through the mesh now. We can see nearly all of the vertices that comprise it. And so this becomes a little bit easier to look at and easier to make sense of. It's a little bit faster to work with. However, we are losing some of that surface quality. So this is something that would be all right for 3D printing. It would be, again, it would be a little bit jaggy. You would definitely get some of these results here. But for the most part, all of the large forms are still being preserved by Blender. It still reads as a simplified version of that very dense model that we had before. Now, this, for example, wouldn't necessarily be bad to use inside of a game engine as long as you projected the higher quality details onto this lower quality proxy mesh, as it's often called. However, you may want to preserve some of that higher level detail. So maybe 0.01 is going a bit far. You could try maybe point 0.5 and see if that helps us to retain some of that detail. So we'll let it run through that really quickly and see what kind of result it returns. So there, we've gotten quite a lot of that detail back. We're up at 200,000 faces or verts and 400,000 faces. And you can see that it's kind of rough in its surface, but we're getting a lot more of that detail back. We can see that there's something in these hands. We can see that there are some striations across this chest piece and the differences between these individual feathers. If I turn the material back on, just wait for it to load back up. Again, it's trying to uh, load all the information on account of the decimate modifier, and we can actually apply this to speed things up later. Now you can see that we're not getting as much of that jaggedness as we had before. We still have a lot of faces, but we are kind of compromising here. So maybe if I put this at point 0.1 instead of 0.01, I think that'll be our last value here. I think that would be a good compromise. So point 0.1, hit enter. And there we go. So we have now a little bit of jaggedness that's appearing here on the model. It's really not that bad. Some of it is not even noticeable when we're zoomed out this far. So again, this sort of thing you can really push it based on how far away the object is going to be viewed at. However, it's not really bad in this case. We can still see some of the patterning that's even occurring here. But there we go. I think that's a decent compromise. We have 43,000 verts, which are 87,000 faces. That's not awful. It'll definitely run inside of Sketchfab. We're still getting that problem on the bottom, but again, you can hide that if necessary. Or you can actually apply a completely separate material to this to make it black or, a dark green that kind of relates to this object. And there we go. We have our model here. So if I switch back into our wireframe mode, again hitting the Z key, we're coming down here and going to wireframe, you can see that we can still see through it. It is quite a bit more dense than what we had before. I can hit Z again, and you can see here that we still have a decent surface quality that has enough detail. If you were to 3D print this, this would definitely show a lot of detail, especially if you used a really nice 3D printer. So if we're happy with that, make sure we're in object mode and we can hit apply and it will apply that modifier. It takes a second to load again because it's rifling through all those vertices and applying all the changes. And before applying this, I would probably save the file as an uncompressed version and then save another one where it's decimated. So you could say original and decimated. It's completely up to you. Again, you have that original file from Meshroom, but we had to do all those transformations to it. But there we go. We have our decimated model. Another modifier you could put on it is the smooth modifier. So that would be over here. And this basically smooths it out by a certain percentage. So 50% of it will be smooth, or it'll apply 50% smoothing one time, which is what this repeat factor is. If we want to smooth it out a lot, we can turn that up to 20 and you can see it gets really smooth. That might be a little too much. So let's try 10 maybe. That looks fine. Maybe even 5. That looks okay. So somewhere between 5 and 10 would be good. I think I'm going to leave it at 5 to kind of preserve that detail. And then I'm going to apply that as well. Again, save a version before you apply your modifiers and then after you apply your modifiers. Um, you can also add the smooth before the decimate or after the decimate. It's up to how you want to handle it. Sometimes modifier order is going to matter. Sometimes it doesn't matter as much, but just keep that in mind. So let's activate our material mode, and there we go. We have our soldier. He's looking rather good. His silhouette reads pretty well. It's been simplified enough that we can definitely do stuff with it, but it's not causing our application to slow down. And there we have it. We have our 3D photogrammetry model taken out of Meshroom. We've walked through the interface of Blender and kind of shuffled around through getting it in the proper orientation, and then we've decimated it and smoothed it in order to bring it to an acceptable state. And now all you have to do is you can save it as a blend file, an OBJ or an STL. You can hand off the OBJ or STL to a 3D printer. Now keep in mind, most 3D printers are not going to make use of texture data. So it's probably going to come out more in the solid view like this. And that's what your 3D print will look like. And that would be pretty cool. But if you upload it online to Sketchfab, which I have a video of uploading files to Sketchfab, feel free to check that out. And or if people really need it, I can show this specific model. But essentially, you can save the blend file. So file, save as a blend file. Go create your free Sketchfab account if you don't have one, or just log into it. Upload the blend file, and then in the 3D settings, find your material settings, and you may have to come back here and upload this texture underscore zero PNG, and apply that to the object. Now, depending on the size of your object, Meshroom may create more than one of these, in which case you'll have to upload them both and map them both to the object. If you watch the video that I've uploaded already on this process, it's pretty easy to figure out. Otherwise, ask me for help, ask in the comments below, and I will be more than happy to help you sort that out. So I just want to say thank you for bearing with me through this process. I hope everybody learned something and that it was useful to you. Again, if you have any concerns or questions or comments, leave them down below or approach me in class or get a hold of me however you know. I'm on all the social media and everything. And I hope everybody has a great project, and I'm looking forward to seeing what my class comes up with. And if anyone else wants to send me work, feel free. And I hope you have a great day, and I'll catch you next time.